Okay, guys, in this lesson, we're going to learn how to solve literal equations and rearrange formulas into new ones. So you can see here, a literal equation is just made up of many variables. The instructions will tell you which term to isolate, which term to solve in terms of the other variables. We're going to use the same properties that we've been using to solve a typical equation. We're going to be working in the opposite order of the order of operations, and we're going to use the inverse operations. So it still applies that addition and subtraction undo each other, just as multiplication and division undo one another, and taking the square root undoes squaring, and squaring undoes taking the square root. So let's take, for example, that we know the Pythagorean theorem, and let's say we know one leg and the hypotenuse, but we don't know the other leg. So we're going to rearrange the formula that we know to isolate one of the leg variables. So let's rearrange, and let's say we want to find leg B. So we need to get the B by itself. So we need to get the a squared term and move it on the right side. So we're just going to subtract this entire term. And we have b squared is equal to c squared minus a squared. Now notice that I put the minus a squared behind the c squared. Now we have to undo the squaring on the b. And remember, taking the square root undoes squaring. And what I do to the left, I have to do to the right for the properties of equality. Now, here we are, we're finished. Don't be tempted to take the square root of each of the c squared and the a squared. It is connected with a subtraction, so it all stays under the radical, so you're finished. So let's say we knew leg B and the hypotenuse, but we didn't know leg A. So we're going to isolate a squared. So we're going to, or just the a. And so we're going to move the b squared, and we're going to subtract b squared from both sides. So we have a squared is equal to c squared minus b squared. And again, when we subtract this, it goes behind the c squared. The c squared was already there. We're going to take the square root to undo the squaring. And then I'm left with a is equal to the square root of c squared minus b squared. Here we have the formula for the area of a triangle. Let's say we know the area and we know the base, but we don't know the height of the triangle. So we want to isolate the height. So the height was multiplied by b and then divided by 2. So we're going to do the opposite order and opposite inverse. So we're going to undo the division first. We're going to multiply both sides by 2. That gives us 2a is equal to b times h. And again, we're focusing on the h. Now we have to undo the b times, and we divide both sides, the division property of equality, and our height formula is 2 times the area divided by the base. Here we have the volume of a sphere, and let's say we know the volume, and we're trying to find out what the radius is. And you notice we have pi as in our formula, and we're not going to plug in 3.14. We're going to treat pi just like a typical variable. So let's go through this. The radius is being cubed, then multiplied by pi and 4, and then divided by 3. So we're going to undo division, and they're going to undo multiplication, and then we'll undo the cubing. So we're going to multiply both sides by 3. We have 4 pi r to the third. We're going to undo the multiplication of 4 and pi, and we can do that in one step. That cancels the 4's and the pi's. And now I have r cubed is equal to 3 times the volume over 4 pi. So to just like undo squaring when you take the square root, To undo cubing, we're going to take the cube root and we just have to write in our little index 3. So taking the cube root of something cubed gives us just that variable. And now we have to take the cube root of the right side. Just don't forget your little index of 3. So we have the cube root of 3 times the volume over 4 pi. That's our new formula. Okay, here we're going to solve for A. So let's find where A is. Again, for the most part, when you're solving for a particular variable, you will not move that variable. You'll move all the other ones to the opposite side. There is a couple of situations that we'll look at where you will, but we're going to leave the A where it is. We're going to move the 2, the B, the C, and the D. So let's talk about what's happening to A. A is being multiplied by 2, then we add B, we divide by C, we subtract D. So we're going to go in the opposite order to solve this. Now, if you didn't know, this long division symbol acts as parentheses for your numerator and then denominator. Okay, so the first thing we're going to undo is the minus D. So we're going to add D, and I'm going to bring it behind the E. Equals E plus D. We got rid of the D's. Now we must undo the division. So we're going to divide both sides. And yes, you need parentheses when we have something such as E plus D, or if it was E minus D, you need parentheses. So we're going to multiply both sides by C. And do not be tempted to distribute that. We don't need to distribute. It can stay just like it is. And so now we got rid of the C's and we're going to subtract B. Remember, this is what we're keeping our eye on, the A. So we're going to subtract B and it comes behind the expression that's already there. So we have 2 times A is equal to C times E plus D minus B. Now we have one last step. We have to undo the 2 times by dividing, and you're dividing the entire expression by 2. So our new formula is A equals C times E plus D minus B, all divided by 2. Okay, let's take a look at this same equation, but this time we're going to solve for a different variable, and we're going to solve for C. So in this case, anytime you have a C in the denominator, or I'm sorry, when you have a variable that you're solving for in the denominator, or if it were in parentheses, we would have to do something to that variable instead of just leaving it where it is the whole time. So let's go ahead and still move the minus D first. So we have 2A plus B all over C is equal to E plus D. Now we're trying to get to this C, and when you have that variable in the denominator, we are going to have to move this right now. So I'm going to multiply to get it out of the denominator. We're going to multiply both sides times C. So this is one of those cases where you will move the variable you're trying to solve for. Now the variable that we're trying to solve for has moved to the opposite side. So we're still keeping our eye on the variable we're solving for. So this is saying C times the sum of E and D. So we really just need to get this part over to the left side, and it's C times, so we're going to simply divide, and because I have this long division bar, I don't have to use the parentheses. And this divides into that, and C is now isolated. I always like to put my variable I'm solving for on the left side. And there we go. Okay, this time we're going to solve for D, so we're going to keep our eye on the D. So we have this whole term minus D. So all we need to do first is get rid and move this entire term. This is one term, Okay, this equation just has two terms, 1 and 2. So we're going to move this 2a plus b over c. We're going to move that over to the right side. So I'm simply going to subtract the entire term, and I'm moving it behind the e. I have negative 1 times d is equal to e minus 2a plus b over c. Now we have this negative 1, so I'm going to divide each side by negative 1. And my d equals, we can leave it like this, or we can distribute this negative 1 into this term e and this term here. So if I divide this negative 1, it makes it negative e, and this negative becomes positive. So I think that looks the best, and we're done. Okay, the next few problems are some problems we're going to look to in future units where we have a linear function, a linear equation, and we're going to put it in what's called slope-intercept form, which is y equals mx plus b. You may have seen this before, but we're going to go ahead and get a head start and practice that now since we're solving for a variable that has other variables in it. So we're going to be solving for y the entire time because we want to isolate the y. So we're going to move this term plus 3x to both sides. I'm not lining it up with 18 because they're not like terms. I bring down the negative 6 times y, and I'm going to move this linear term to the front and put my constant in the back, which lines up with our formula here. And now we just need to divide every term by our coefficient of negative 6. And then we have a negative 1/2 times x minus 3. So when you have a fraction, you can put the negative with the numerator, you can put it with the denominator, or you can put it out front because the entire expression is the 1/2, and anywhere you want to put the negative indicates it's a negative 1/2. Okay, we're isolating the y. So we're going to move the term 6x. We have 2 times y is equal to, again, I'm going to put the linear term and then the constant. I'm going to divide every term by the coefficient 2. And I have y is equal to negative 3x minus 9. Again, this is slope intercept, where m is your slope and b is your y-intercept. We're going to move the minus 4x, so the addition property of equality. Again, the linear term and then the constant. Divide by your coefficient 12. Y is equal to, so 4 over 12 is the same as 1/3. And then you have your x and then minus 1. Okay, pause the video, you try these, and then when we come back, we'll go over these together. Okay, let's solve for a on this first one. It's not in the denominator, so we're going to move the 3, the b, the c, and the d. So a was multiplied, so here's my little plan. So it was multiplied, and then it was subtracted, and then it was divided, and then we added to it. So here's the operations that we would use for order of operations if we knew the value of a. And now we're going to go backward and undo each of these in the opposite order. So we're going to subtract first. And we're going to bring that d behind the e. Now we're going to undo the divide. So we're going to multiply. Yes, you need parentheses. Do not distribute, just leave it as is. Now we're going to undo the subtract, so we're going to add B, we're going to bring it behind. And now we're going to undo the multiplication by division, and you're going to divide this entire expression by the 3. So we have A is equal to C times the difference of E and D divided by 3, and then plus B at the end. Okay, on this one, same equation, but this time we're going to isolate the B. Okay, so let's work backward, and we're going to still get rid of the plus D, then we'll get rid of the divide, and then we'll get rid of the 3A, and then this understood -1. So let's subtract D from both sides. Again, bring the D behind the E. Okay, we're going to multiply with using parentheses by C. And again, keep your eye on the B. We got to get rid of the 3A, so we're going to subtract 3A, so it becomes 0. You're going to bring the 3A behind the already existing term. Bring down negative B equals C times E minus D minus 3A. So here we have two terms. This is one term and this is one term. So now we're going to divide every term by -1. And this gives me B is equal to, I'm just going to bring the negative out with a C. And then negative over negative is positive 3A. And that's it, guys.